This conference will now be recorded.
Hey, hello. Good morning, everyone. I hope you
Morning.
guys are able to hear. Yeah, perfect. So you guys are able to see my screen and my voice is clear, right?
Yes.
Perfect. So unfortunately, right? So that demo presentation right now I'm not having with me. In our next class, right? I will share that one. So quickly introduce myself. So myself, Shankar, and I'm having around 11 years of IT experience, and into the DevOps, right? I have more than 7 years of experience. So this is about me, and I'm working in a product-based company. So I don't want to take much time introducing myself. So guys, if someone is unmuted, can you guys mute yourself? It is disturbing the class actually. So if any questions of you right, you can unmute and you can ask me. Until then, please mute yourself. All right, right. So today we'll discuss about what is a DevOps, and in the DevOps, right, what exactly we are going to do, right? Nothing but the roles and responsibilities, what kind of automations we are going to implement as a DevOps engineer to implement that automations, right? What is the tool stack, right? The tool stack which we are going to use in our area, and right, followed by questions and everything, right? So then we'll see that what extent we can discuss. Maybe otherwise tomorrow, right? We can plan for tomorrow the extension. So, right, I think you guys are all know about the application, right? The product. Suppose if I'm going to take an application like this is my banking application, right? So this banking application, right? So is going to have different services like credit card service, debit card service, mutual funds, online banking, like that. This this application will be having different services like that. All we right, we are working with plenty of applications like Facebook, right, Flipkart, Amazon, banking apps, marketing apps, right, e-commerce apps, like a lot of apps we are going to use. So now to run these applications, right? So now somewhere, suppose if I'm going to check with Flipkart, right, I want to buy a product from the Flipkart. Now what I will do, simply I will go to my browser and I will hit the website link like flipkart.com, correct? So then it is going to respond to me, like I will get the Flipkart homepage, then from that I will go to the services whatever is available by the Flipkart. So now how the response I am receiving, right? Because just I'm hitting via the browser, right? So simply I'm sending a link, the request like flipkart.com. So how I'm getting the response, correct? So now for that, right? For that, in the backend, in the backend, the application is running on some servers, right? So it can be any application. It can be any application. The the apps are running on some servers like this. Suppose this is my app, so now this is deployed, running on a mission. Now this is a server. Right, so now somewhere the application is hosted on a server. It can be in our country or outside of the country, right? The data center, wherever the data center is. Now, whenever right we are going to send a request, our request will travels, like it will go to the server and it will hit the website. Then the application will respond to us, like that process is. So now, once my application is running, is this simple, right? We can leave it so that the application will go and run something like that. No, right? So because on a single mission, right? On a single mission means a server running my application, right? What is the guarantee that always my application is up and running? Always up and running. What? Because right, some point of time the server may go down, right? Or some point of time the application is not responding from the server. Like there are different factors will be there, so that there is no guarantee that right your application always be up and running. So now we have to make sure, right? So we have to make sure application is always up and running, right? So for that, what we will do, we are going to set up a high availability, right? Now from one server I am going to deploy on multiple servers, so that if one server has different issues, right, on the server the application has different issues, the other server will be available for us, right? So now this concept will be called as high availability, making sure your application is always up and running, right? So as a DevOps engineer, right, now what is the job we are going to do? We are going to set up, the automations to make sure application is always up and running. One of the role for us, what is that? High availability. So then suppose, right, you guys all know, right? So recently, right, last month we have the big billion day offers, Amazon, Flipkart. So by that time, right, lakhs of requests will go to servers. So now, is these two missions or five missions or 10 missions are enough to handle those many requests, right? So no, obviously no, because right, so 2 or 10 missions cannot handle lakhs of requests, right? More than lakhs also. So now, what is required here? We require some setup, some automation. That is nothing but scalabilities, right? So now here you are going to scale the servers. We are going to scale the servers whenever the load is coming like this, number of missions. When when the load is hitting on the application, on the application servers. When the load is going down, right, we are going to remove the servers. Right? So this is something called as a high scalabilities. So now as a DevOps engineer, right? Again, this is the other role for us, scaling the apps whenever is required. Scalability. Right. So the important areas to run an application, right, as a DevOps engineer, we have to make sure these things are taken care. So then the other role for us, security. Right? Because right, there are hackers will be there in the backend. So whenever they will get the chance, right, they will try to hit the data, they will try to steal the data, then again, right, this is a kind of mess. So now we should be very careful while deploying the applications on the servers, how securely you're deploying it, right? So how securely, right, we are going to deploy the application, so that, right, so these hack things can be handled. right? So high availability, high scalability, security, right? So these are all the areas for us. So then, so then, so usually, right, these applications, like it can be a banking or it can be your right e-commerce application, whatever the application you're working for. So usually, right, so who will develop that code? Developers are the responsible persons. They will develop the code, right? So now, suppose I have a developer or a developer team. So now this guy is working on right debit card module, the service, right? So now this guy is ready with the code, the debit card module code. Right? Suppose they have received a request like we required debit card EMI facility, okay? A new feature we want to add for the debit cards. Right? In the past, we don't have that kind of facility. Right? We don't have only for credit cards. We'll be having the EMIs, but not for the debits. But later on, they have introduced debit card EMIs also. Right? So now this enhancement, right? They want to deploy into like they want to have it into the application. Right? So now the requirement received and the development team developed the code. Right? So now this code, right? So this code is in my production server where the application is running, like banking application is running on the server. Now this guy download the codes. Shall I go and deploy the code straight to the server where the actual application is running? Because right, we want to have that feature so that right the customers can avail that EMI feature for the debit cards. Now code ready, and you have the production servers where the actual application is running. So can I go and deploy the code straightforward? Right? No, we cannot. Right? So we cannot go and deploy the code straightforward because what is the guarantee that whatever the code is developed, it is working fine? Who approved it? Then what is the guarantee that your code is not going to mess up the other services? Right? You develop a code for the debit card. For the debit card, it is working. When I deploy the code into the server, like into the whole application, now it is impacting the credit card. Yes, there are chances are there, right? One service can impact other service. So now, what is the guarantee that your service, your changes are not impacting the other services? And what is the guarantee that right, your application performance is as it is? Means before my changes, when people are sending the request to the application, hardly it will take right off milliseconds the response time. After the changes are right deployed, now it is taking 1 second. Not acceptable. So because right, so application performance is very very important. Then what is the guarantee? Now who approved it? All these things, right? So that's where whenever right a code is ready, so are we going to deploy the servers? No, we are not going to do that. We require the proper approvals. Right? We'll be having different stages. On the different stages, right? We should get the proper approval. Then only it has to go to the main servers where the actual code is running. Right. So now, what are the approvals are required here? What kind of approvals are required here? Right. So let's see now. So I hope you guys are following me. If anything, right, do let me know. So yeah. Now this is my developer and this is my production server. Right. So when the code is ready, right, whatever the code that developed, when the code is ready, the first testing stage will be the developer mission. Now this is the developer mission, like workstation. Now what like workstation means the laptop or desktop, what are the machine we are going to use. So now first as a developer, what I will do once my code is ready, I am going to test the code in my mission so that I am going to make sure my code is working fine. For me, yes, it is working fine. Like I mentioned, right, the point one, what is the guarantee that right your application is not impacting the other application, means sorry other services. like your debit card is not impacting the credit card or online banking or mutual fund like that. So means you have to test your code with the whole application. Now on your machine, right? So you tested the piece of code, whatever you developed, that is working fine. But now I want to test with the whole application so that I will make sure, right? I will make sure my application is working fine, and also I will make sure my application is not impacting the other services, right? So where now this testing where I can do, because on my machine, if I'm going to deploy the entire application, it might consume my system resources, my system may go slow down, right? And also, right, in my system the entire setup is there whatever is required, but when you go to the real time, means into the live, so whatever the dependencies are required, that will be available on the main servers. So that, right, we should test on a separate area, so that we are going to make sure the application dependencies or the services what is required we are going to set up, then on top of that this application is going to deploy, so that on the live we are not going to face any kind of challenges. So that's where, right, so the concept came into the picture is environments. So now, before going to the live, now the code is going to tested on the environments, right? So what are the environments are here? Like we are going to have the first environment called dev environment, developers environment. Dev means developers environment. What is an environment here? Right? Environment can be, right, a group of missions. Simple, right? Here, this is my dev. So here, like I can have a couple of servers or more than, right? Like these are the servers. The teams are going to use these servers to test their code. That's called, right. The first environment will be the dev environment, right? So now, once the code ready, it will be tested on the local. Then from the local, right, it will go to the dev environment. So there the entire application will be tested. So now before going for the testing, right, we need to make sure the prerequisites. As an example, I have a PowerPoint document with me. I want to open the PowerPoint, right? But in my mission, right, I don't have the MS Office, right? That is what the prerequisite, right? I have a Java code with me. I want to run the Java code, but in my mission, I don't have the Java, right? Java is a prerequisite. Likewise, whatever the code got developed, right? When you want to run the code, whatever the application or the language or the tools or the dependencies, like whatever is required, we need to make sure they are already placed on the server on the machine where you want to run the code. Otherwise it won't work for us, right? So that's what the setup. So now, so right, so suppose this code is going to tested on these two missions. Now what we need to do on these two missions, we need to make sure the prerequisites are, right, there on the mission. Like it can be anything, any like configuration changes or any installations, right, or any, right, or any services enable or disable like that, or any database updates like that. Now who will do this, right? Making sure the servers are ready with the setup. Who will do this? Again, the DevOps people, right? So that we are trying to understand, right, what the roles we are going to do, right? So now the DevOps people are the responsible person to make sure on the servers the entire setup is there so that the application can be deployed, right? Right. So now here the development team validates their code on the dev environment. So right, so they will validate the different scenarios, so that, right, once they are satisfied, right, with their changes, like everything working fine as expected as per the requirement, so then it will go for the next level of approvals, nothing but next level of testing, right? So now here, so I might test only few scenarios, right? As an example, right? A simple example to understand better. So I have written a code like A greater than B, then A is bigger, else B is bigger. Now this is my logic, right? So can anyone tell me the test cases for this code? So that right, we are going to make sure this code is right, working fine as expected. What kind of test cases we can provide here? Can anyone? Expecting answers, right? So now here, that is the logic is written, and right, we want to write test this code. No, fine. Let's go for that. So here, so I will pass a equals to 10 and b equals to 20. This is my test case one, and my test case two, right? A equals to 20 and b equals to 10. Right. So the right. So it will the first one validates right the else part, right? The second one validates the first part. So that right. So I'm going to make sure the entire code is working. So any other test case can be done here, or these are enough.
where A and B 10.
Yes. If both are same, right? Then what equals to correct only, right? Perfect. So like these are the right. So now here, as a developer, right? So a simple example right here, as a developer, so I might not be right go with all the cases. I will take the requirement. As per the requirement, I will implement it. Now someone is required to go through your entire code and check all the cases, so that we are going to make sure right the application is working with any scenario, right? So for that, right, we are going to use the other environments. Like here, this is our next environment. I'm going to call it as a QA, quality assurance. All right, so now this code will go from the dev to QA. So now again, on the QA environment means like bunch of servers. Again, the same thing. So now on the QA environment, whatever the servers, the machines we are using for the testing, again the DevOps people needs to make sure that the prerequisites are there, the setup is there, so that the code can be executed on the machine. So then the testing team, right? So here the testing team comes in the picture, right? So now they will write the test cases, the test suites, and they will run on the QA servers, so that they are going to check the different scenarios on the code, and they will give the approval if everything works fine as expected, or they will not give the approval. Simply they will send back the feedback to the team. Hey, these are the things are missing, make sure they are ready. Again, the dev team is going to work on the issues, and again they have to push the code back to the QA. Likewise, it's a cycle, it's a process, right? So once the QA, as an example, right, so the QA team has given the approval, right? So then it will go to the next environment. Like, so I'm going to call it staging. People are going to call staging UAT like that. Staging or UAT both are same. Staging environment or the UAT environment. User acceptance testing. So now here it's the client side. So now whoever is the client side we are working for, from the client side, there will be a team. That team also going to validate the code to make sure right there your code is meeting with the requirement. Right. Again, the server setup, who will take care? DevOps people. Right. So everything we are going to make sure then the code will be validated on the next environment called staging. If everything fine, right? So then they will give the approval. Again, any issues, they will send a feedback. Once right, we got the good feedback like approval is given, then finally right, it will go to the live, like our production environment, prod environment, right? Now see the life cycle of a product, right? So once the developers are ready the code, they will test on their local. From that local, it will go to the environments. The environments like right, dev, QA, staging, production, like in between, right? You might see in different environment also. Like for the performance testing, you can have a different environment as part of the project setup. But typically, right, these are the environments we are going to manage most of the applications. It depends. It depends on the project. The environments may increase or decrease. But anyway, whatever the environment they are using, our job as a DevOps engineer, our job is to make sure the servers are ready with the setup. So that right, so no one is going to point out right because of this issue, the application not responding or not working properly. Right? Who is responsibility? DevOps responsibility. Not like that. Anyway, right, we'll discuss how we are going to set up everything, the automations. Trying to understand right the roles, right? What type of roles we are going to play here. Right. So now I hope right until this point we are clear. You guys are following me. If anything, right, do let me know, guys. So now this area from the developer mission to the environment. So this area. So that area means are we going to take the code from the developer mission to straight forward into the environment? Again, no, it is not going to happen like that. We'll be having a process. We'll be having a process. That process we are going to call it as a CI and CD process. You guys heard about the wording, right? C and CD. Continuous integration and the continuous deployment process. C and CD. Right. So right. So now what is the DevOps here? Right? DevOps is nothing but it is a practice. It is not a specific tool or technology which we can use and adopt and use it. Right? Not like that. It is a practice for us. Right. So nothing but by using different tools, by using different tools, we are going to set up the automations, different kinds of automations like CA and CD setup, continuous integration and continuous deployment setup, like environment setup, like whatever we discussed, right? The dev QA, the environment setup, or infrastructure setup, like creating all the servers and the required components. Like what the components, like security, high availability, high scalability, all those things, infrastructure setup. Right. Likewise, we are going to play different roles based on the project. Right. So that's why right, DevOps is not going to have a specific definition. It's a practice how we are going to set up on your project by using various tool stack. Right. What are the advantage of the DevOps? Right. The major issue with the production setup or the application setup, right? We are seeing the dragging of the time. Right. So one environment is working fine, the other environment is not working. So here the code is working, there the code is not working. Right, likewise, right? So these kind of issues we used to face in the past. Now with this automation, right? So now we don't require a separate team. As an example, right? If I want to install some packages on a mission, right? So now who is required? Ops team is required. Operation team. Those guys are will like I have to give the requirement to them like I need XYZ dependency, I need Java 11 like that. So now the ops team will take the requirement and they will install it for you, like the Java 11 and XYZ dependency. Now what is required for the XYZ? XYZ 2.0 is required, but here they install XYZ 1.0. That's it. Your code is not working. Then again, the blaming game, right? You are not mentioning the version. That's why I have taken the latest, or I have taken some whatever is there, right? So like right, I need a mission so that I want to test my code. Is a new mission so that I want to make sure the required dependencies, packages, everything is there. Then I want to test the code. I need a mission. Now again, I have to send a request to the ops team like, hey, give me a test mission so that I want to test the code. And on the mission, set up these things. Again, the approvals, it will take 1 day of time, 2 days of time. They will allocate a mission for us with all the prerequisite. If everything fine, it will work. If right, if something wrong, again you have to go back to them and ask them. See, again, it's a kind of cycle it is. Right. So a lot of right dragging out the things here. If individually teams are very good, but when they're right, when they're working as a team, so these kind of challenges used to face in the past. So now what we did, right, don't go for like asking these things and that thing. Let's make it an automation. Right. What kind of automation? Hey, I need a server. Hey, here is the code. Trigger the code. Who will give the code? DevOps people. Now, as a DevOps engineer, what I will do? I will create a code, a automation code. Now, what the team will do? They simply they will use the code, trigger it. It will create a mission, and you have to pass the input Java 11, XYZ 2.0. That's it. You will get a mission. On the mission, right? You will get the XYZ 2.0 and Java 11. That's it. They will test it, right? So, likewise, right? We changed the process now. With our automation skills, we change the process. Now here, you don't require to depend on a separate team, right? So we will be having an automation, take the automation and use it so that we can save the time. Once you save the time, then right, so the deployment, then the dragging things will be gone. On time we are going to deploy the code, right? So right, so what we are doing right now as a DevOps, right, we are going to collaborate, we are going to right work with the teams, and we are going to work with the teams. Then you will see the issues in which area the teams are facing the issues. Now we are focusing on those areas and we are trying to automate those areas so that right it will helpful project time and cost, right? So you are going to save a lot of time and you are going to save the cost, the resources cost, right? Earlier, right, I need a mission, take a mission, then what about that mission, right? I need some setup, install it, and what about that installations, right? So right, so here like that. So now here, when you want, take it. When you don't want, leave it. Means terminate it. Don't keep with you. When you want it back, again take it back, because you have the automation code. Hardly will take seconds or minutes to get the things back. You don't need to maintain all the things, right? So like we said, now the DevOps is playing very important role in our IT, like application maintenance area. So that's why, right, one of the highest paid job in the market is DevOps, because you are not going to touch one single area. If you have the skills, you are going to touch a lot of areas, right? Because there is a lot of areas are there, right, to automate the things, like we discussed, right? So like usually, right, people think that DevOps is nothing but CI/CD. CI/CD is one part. That's it. CI/CD is a one part for us. Not that is not the DevOps engineer's actual job is, right? So CI/CD is a job will do in the past. Build and release engineers. We have a team called build and release engineers. Their job is the CI/CD, right? So now earlier, right, we have taken that area, we automated now. We are right spreading into the other areas also. Like right again. So DevOps people will be used, right? The areas wherever the teams or the projects facing the pain, right? The issues. Those areas are targeted by the DevOps engineers. Simple definition, right? So now we'll discuss about the CA and CD process, right? So there we'll discuss about right the infrastructure automations. Like I will try to right show you right how the automations we are going to set up with our skills. Nothing but right again the tools and tools we are going to use in the backend. Right. So earlier, right. So this entire process, right, is maintained by different teams. Application development to the live, from the development to the live, right? Different teams are going to maintain, like right, the developers, build and release engineers, testers, ops team, right? Like right, will be having different teams. But now in the backend, right? So now developers, DevOps, that's it, and testers. No ops, no build and release engineers. Right. So now the end goal, right? The end goal for the DevOps is in future, right? Maybe not immediately, right? It will take some time. Not sometimes after 5 to 10 years. Like I think you guys have heard about full stack engineers, right? Full stack means they will do everything. So now this automations also they are going to do it, the full stack people, right? So now we don't require a separate DevOps engineer, separate role. Yes, full stack engineer will be there. They will develop the code, they will create the infrastructure, they will set up everything, they will test it, they will leave it like that. That is the end goal for the DevOps, right? So that, right, you don't require to dependent on any person. You know everything. You have the automation codes, automations are there, just take them and use them like that. But anyway, that is a future story, but it will take some time. Not some time means yes, it will take. So now, right, so let's focus on this CI and CD process, continuous integration and the continuous deployment process, right? So I will take a pause here. Guys, any questions? Are we good? If you are good, right, I will continue. If any questions, do let me know, guys. Following me? So yes or no, at least.
Y- Yeah. So what is the difference between DevOps and Ops? I mean, we do have some operations teams, right?
Yeah, that's what. Right. So ops team job is to maintain the servers, infrastructure, the servers, the setup, like we discussed, prerequisites and everything. So basically, right, they will focus on the, right. So on the servers, the OS side thing, right? OS security is important, like installation patches, maintain the users, right? Then whatever the application is required, the setups, the ops teams. So right, so now we are taking their roles also, right? So like here to install an application, whatever is required, that is from the DevOps engineer. So now if some teams, some projects are maintaining the ops team is, they will take care of, right? So the OS maintenance, the server maintenance, like users maintenance, OS patches, server backups, like that. But right now, right, like I mentioned, right, most of the projects not maintaining a separate ops team, is a DevOps team only. So right, so if no questions, right, so then let's discuss about the CA
I
and
do have one more question. So
yeah,
this load balancing part, does DevOps take it, or is it Ops team?
yeah,
Oh,
that's all
I'm
right.
just
So now,
wondering who will take care of this load balancing and CDN kind of stuff.
yeah, yeah. Can you cool, right? So high scalability, that like I mentioned, right? High scalability, high availability, security. Nowadays, DevOps engineers are maintaining. So right, so that's why, right. So ops team, again, the thing is, right, based on the application, based on the project. Now, right, so now here, so there are projects are there. It's like, suppose if I'm going to talk about the Flipkart or Amazon, right? It's a huge one. It's not like a single DevOps engineer or group of people can manage it. Now they'll be having the separate areas. Like there, you will see a separate admin team, like ops team. It's separate DevOps team for fully focused on the automations. It's separate. You might see it separate only for the CACD, like that, right? You can see different things because of the application, the nature of the application, right? So there they will take the roles. Like now here, the scaling, high availability, scalability now will take care by ops team. But now if I'm going to talk about, right, the project, like suppose if I'm going to talk about project like Big Bazaar, right? It's a simple application, like not having that point of view. Now you will not be having any ops team separately. There is no ops team. Only the DevOps team will be there. They will take care of the load balancing, auto scaling, like whatever the CDN things, whatever you require, right? Everything we are going to take care. Right. So now we should be ready, right? We should be having a knowledge as a DevOps engineer. We should be having a knowledge all these areas so that at what point of time, what kind of role you are going to play, we don't know. Based on the project, right? You are going to play different roles. Right. So you should know the scalability, right, availability, the security part also. It's not like only one area I know, I will work on this area. That's what I'm trying to convey you guys. So our roles not like a simply CACD or not like a simply infra management. We are going to play different roles by using. the tools available in the market. Yeah, in my previous project, right, we are the team, like the DevOps team is going to take care of everything. We are the persons to take care from the infra from the zero to right to set up the entire automations. Everything we used to take care. In my current project, we have a separate team. Like they will take care some part. We will take care some part like that. Clear?
Yeah, yeah. So hopefully we are going to discuss all these things going forward, right?
Yes, yes, yes. So this scalability, everything, right? We'll see with the practical also,
Oh, thanks. Thank you.
right?
Or you have to explain
Right.
the Azure and AWS and GCP also in cloud system.
No, no. So it will take a lot of time going with all the tools and everything, right? Because in the market, right, for every tool there is a competitor, right?
Mhm.
Right. So if I'm going to talk about the CI/CD, I can do with the Jenkins, I can do with the GitHub, I can do with the Azure DevOps like that, right? So we'll try to focus on one guy. Like suppose I'm going to focus cloud, we'll focus on AWS because the majority of the right, market is AWS. Most of the projects are in AWS. Now Azure will be the similar. Our GCP will be the similar. We don't require to learn again separately.
Mhm.
Right? As an
Okay.
example, right? As an
That
example, I want to create a server.
that
Yeah.
interfaces will be different, right? The same
Yes,
thing different, but
yeah,
interface are right.
yeah, exactly correct. Right. So there, here we have called EC2 instances. They're Azure virtual machines. The
Mhm.
interface, like you mentioned, yeah. So understanding the particular service will not be a problem for us. It will not be a hurdle for us. If you know one cloud, working with other cloud will not be a like hurdle for us. Hardly you have to understand the terminologies, the interfaces, the option. That's it.
Mhm. Okay.
Right. Like
Yeah.
that, we'll focus on the important tool stack and this AWS cloud because
Mhm.
based on the market, right? The market share. So then going forward, right, what is going to happen when you are working with other tools? It won't be any problem for you because you know that the tool already. But it is something else is there. You need to understand the extra things, the extra features or whatever they're providing to us, like that.
Mhm. Okay.
Yeah.
Understood. Thank you.
Yeah. Cool. Yeah.
Yeah.
So then let's go to right our CI/CD area, the major part of the DevOps. Right? Most of the people, most of the projects, the DevOps engineers are being used for the CI/CD setups actually.
Mhm.
So now let's go here. Like here, I have the different teams, like my development one team, and right, I have the development two team. Like suppose I have two teams. So now these guys are working on right one particular piece, like a debit card module as an example again. So now these guys are working on the credit card module development team too. So where this code is going to maintain. So whatever the code right I have developed, where this code is going to maintain. Usually right, I'm working on my mission. So usually the code will be in my mission. Right. So now this development one dev one team, right? We have like three people, like developer one, developer two, developer three, like that. Right. So now some piece of code of the debit card developed by developer one. Now this guy requires that piece of code so that right he can enhance more as an example. So now if the developer one is maintaining the code on his mission or on her mission. Now when the developer two requires the same code to enhance, so now it's a dependency. The person has to reach the developer one like asking, hey, provide your code so that I want to enhance it. Right. So now, so these are like suppose developer one is not available, then he has to wait for the developer one again, right? So a kind of dependency got created. So now what we need to do here, right? Avoid the dependency means don't keep the code with you, right? So keep it someplace, some area like here, right? Like our external hard disks, right? We can keep the data so that anyone wants to take the data, they can connect to the external hard disk and they can copy the data. Like just suppose I can right place in a server. So now whenever the code got ready, right, don't keep with you, push it to the server so that So now the developer two wants the code. Now he don't require to go to the developer one and take the code. Simply the person can take the code from the server. Dependency got resolved. Right? Now, so now right, we have a requirement like the login page, the application login page. So usually username and the password, then the submit button. So this is something right is developed. Now the client right asking to add extra button called cancel. Now this is the login page developed and working fine, tested and deployed and in the production right is working fine. So now we got the requirement to add a cancel button. Now what we will do right, what the team will do. So where the code is present right now in the server, right? From the server, right? The person right whoever is working on the code, he will take the code or she will take the code and simply on the page, right? They will add the cancel button also. They have taken the code, in the code they have added the cancel button. Perfect. Now it is tested in all the environments working fine. Then when went to the live, right, into the production, it got failed. When I deployed, right, the application, right, like the login page into the live, it failed, not working. Now people are not able to access, means log into your application because the login page has an issue. Right now, assume right the Flipkart or Amazon, the e-commerce sites having this problem just for 5 minutes. How much business they are going to lose? Right, just for 5 minutes. So right, so now we have to resolve the issue. Right, the login page has an issue. We have to resolve it. Now, how to resolve it? Right, means resolving means so whatever the new code you implemented for the cancel button, take out the code. That's what right. So now what I need to do, if I know the issue, I can fix it up. Like what the issue. But if I don't know the issue, then right, if you are trying to figure out the issue, then you will take right more time. Now that is not acceptable because right on the production it got blocked. Now immediately what you can write, you can take out your code back, revert the code, revert your changes, then right, push the old changes. So it is a one line change or 10 line change, we can immediately right revert the code. If the changes are not very huge, right, multiple files, hundreds of lines of code change, then are you going to revert the code, entire code? No, right? There is no guarantee. You might miss some changes, right? So now even the reverting also cannot be done immediately because of the changes. So now we are not able to figure out the issue. We are not able to revert the issue, means the changes. So now right, so now the client, yeah, so it's a high escalation. So now what we have to do it here? What we have to do it here? Whenever you are trying to go for a changes, don't go and apply the change straight for the code, the existing code. Don't go and straight for apply the changes. So what the best you can do, right? Whenever you got the changes, take a copy of it, right? Take a copy of it. So then add the cancel, like what are the changes you are trying to do? Add on the new copy, right? Like this. And so now deploy these changes on the server. If it is working fine, we'll good. We can go with. If something wrong, immediately take the previous copy and deploy it. So that right, you don't require to spend the time to figure out the issue or right, take out the changes. It will be helpful here when you are going to maintain the copies. Now, who will do this for you? Maintaining the copies of every change. Right? If you are trying to do it right, it's again you have to right, make sure everything is properly taken the backup. Otherwise, again, it's a mess. Right? Like 100 files of changes, 100 files copies, right? So now see, it's a complex thing for us. Right? So that's where we have the tools called version control tools came into the picture. Right? Version control tools. like GitHub, SVN, Bitbucket, Perforce, like that. Now, what these guys will do, you don't require to worry about the history, the backups. I will take care of those things. You focus on the changes, on the code. I will take care of the rest of the things. I, in the sense, the version control tool, right? So when you save it immediately in the backup, it will get a copy. Even if it is a single character change, one character change also, it will get a backup for us. Right, so now a lot of pain is gone. So now simply I can focus on the code development and I'll place my code into the version control tool, not on the servers. So simply whenever my code is ready, simply I'm going to push to the version control tool so that in the back end it will take the backup for us. At any point of time, you can pick the backup, nothing but the history. All right, so now why we are going to talk about the developer thing here? Because we are the DevOps engineers, why are we going to talk about the version control tool and all the story? Right, like I mentioned, right? We are going to automate the things. It can be infra, it can be environment, it can be your CI/CD, or it can be your monitoring, right? So we are going to automate. How we are going to automate? With the GUI? No, with the code. We are going to automate with the code, no GUI. So when you are trying to write the code, where you are going to place your code, where you are going to maintain the code, same version control tools. Because we are also going to write the code. Now, where I'm going to maintain my code, right? In the version control tool. It is not only for the developers, it is for us also. And we'll see what kind of automations and everything. But yes, the version control tool job and how importantly it is going to play in our area, in our IT area. Right? So once we received the code to the version control tool, so then we are going to use a tool called integration tool. We are going to use a tool called integration tool. Nothing but Jenkins. Right. So now this guy, whatever the code got received, it will take the code from the version control tool. The Jenkins will take the code. Now in the Jenkins, right, what we are going to do, we are going to create a jobs. We, in the sense, DevOps engineers. DevOps engineers are going to create the jobs. What is a job here? A job is a set of tasks. A job is a set of tasks. So we are going to place a group of tasks in a job. Now what the Jenkins will do, it will trigger the job and it will go task by task. Task 1, execute it, pass. Go to the task 2, execute it, pass. Task 3, execute, fail, stop there, intimate the team. Likewise, so whatever the tasks you mentioned in the job, those jobs are going to triggered by Jenkins. Right. So now what kind of task you are going to place it here? In the job, what kind of task you are going to place it? So whenever, right, so like here, suppose I'm going to discuss about a sample job here. So whenever, right, the team push the code to the version control tool, right? So then in the Jenkins, right, you are going to create a task 1 here, pull the code. My task 1 will be pull the code, pull the latest code, whatever the team is pushed. Right. So now integration, the Jenkins is an integration, means work with other tools. Like here, it is going to integrate with the version control tool, like here GitHub. For the task 1, now Jenkins will integrate with the GitHub and it will pull the latest code. Alright. Now once the Jenkins receives the latest code, then the task 2 will be run the unit test cases. Right. So now here, so previously, right, we discussed about some test cases like A greater than B, right, or B greater than something like that. So now what we will do, right, once the code is ready, once the code is ready, the developers are going to make sure their code is working as per the requirement. The code is working as per the requirement. So now how they are going to make sure that the code is working as per the requirement? For that, they are going to write some unit test cases. They are going to write some unit test cases. Like here, suppose if I'm going to take the sample project, so now this is the source code, right? So here you can see this is the folder where the main code is going to place. Like here, main Java, right? See here, hello world subject Java is the code dot Java file, and this is the sample code. Now for this sample code, right? They will write the test cases like unit test cases. Here test, and you guys can observe here unit test cases. So that right, these test cases are going to make sure the code is working as per the requirement. So this is the developer's job to provide the actual code and as well as the test code also, right? So now what we will do in our process, right? We are going to run those test cases, right? You are going to create a job, and the job, the second task will be run the unit test cases. So how we are going to do it? You are going to use the build tools, right? Suppose this is the code, like Java code. So right, I'm going to use a build tool like Maven here. If it is the code is the .NET code, right? We have the .NET test is there. Like we have the different tools to run the test cases based on the application, right? We are going to use the respective tools. Java application, Java test, Java tools. .NET tools, Python tools. Like that, right? We are going to integrate. Someone is unmuted. Can you mute yourself? Yeah, thank you. Right. So now here, so we are going to integrate again, right? The next tool, like the build tools or the test tools, to test the test cases. Right. So once all the test cases are passed, then we are going to have the third task, the code quality. The quality of the code we are going to check. Right. So what the quality here, right? If there are any bugs or any vulnerabilities or any code smells, like all these test cases are covering the entire code or not, like code coverage, that everything we are going to test it. So that, right, no manually go and verify your code. Suppose, right, my lead wants to see, right, is the code is properly developed, what is the quality of the code, right? So I cannot go and give you, right, every line explanation like, yeah, this is the code I have written, it is working fine. Simply I'm going to send a report, like this is the report, you can check it. Now the, like, the leader manager can check easily, like how the code quality is maintained, right? So now here, if all the test cases are passed, then we'll go for the quality checking. Suppose if any test case are failed, then what you will do? Your job will be stopped. What is job, right? You are executing on the Jenkins, that will be stopped, and it will go to send a communication to the teams saying that your test case are failed. Go and fix it. Now again, the team has to fix the issues, and they have to push the code back to the version control tool, the Git. Now again, your job will take the latest code and will go and execute it. That is a life cycle. That is a process. It's a cycle process for us, right? If the test cases are passed, then it will go for the quality checking. Right? We are going to place some gates here, like coverage should be greater than something, or right, bug should not be more than 100, like that. We are going to put some gates so that your job is going to validate those gates. If the gate is passed, then only you'll go for the next step. Otherwise, again, fail the job and send a communication to the team. Like here, we are not maintaining, right, your bugs more than 100 in the code. We have more than 100 bugs out there. We are not accepting it. Right. So now, right. So now for that, what tool we are going to use here? The Sonar Cube. The Sonar Cube is the right code quality tool we are going to use in our process. Right. If the quality, right, if the code quality is passed, then what we'll do? We'll create the artifact. Create artifact. So now who will do the for us? Again, the build tools like Maven here. Right. So what is an artifact here, right? So here the person has implemented like emi.java, David got emi.java something. right? So now on the server, you are not going to run the same Java like that, because right, the servers are not able to understand the formats. Right? They require their understandable format. Like here, for the Java, right, it is a jar files, war files, like that. For the .NET, right, DLL, exe files, like that. They require their understandable formats. Now, who will do that for us? That's what the build tools. The build tools, right? They will take the raw code, like the .java code, and they will convert into, right, the artifacts, something like suppose emi.war file, so that your servers can understand this format. Like what type of servers? On your environment, like dev environment, Q environment, there we have the servers. Those servers are nothing but your web servers, app servers, database servers, like that. Now these servers will understand, right, these formats, like the files or DLL files, like that. Now who will convert that format? Those are nothing but our build tools, right? So now what we will do in our process, right? Once the validations, right, these two are validations. Once the validations are passed, then we'll go and create the artifact. Then what you will do, right? You will store the artifact. Now in the job, the next task will be, right, store the artifact. Right? What is the advantage storing these artifacts? Right? Because already my GitHub is maintaining the every copy, every changes. Again, why should I store these artifacts? Right? So like we discussed, right? So here we have the login page issue, right? So my login page initially with only submit button. My login page, right, version 2 is with submit and cancel, right? So now this version 2 has issue, then right, we'll deploy the version 1, like it is working one. Now is your servers, right, is able to understand this Java format, because right, the code is the version control tool is maintaining your raw code, like whatever the developed code, like here login.java, login hyphen version 1.java here, and this one is login hyphen version 2 as an example. So now, right, so now the for the problem I have the solution. Like here your latest code is not working, simply I can take my previous changes, I can run it. Yes, I have the solution, but is my servers can understand this code? No, right? Just now we discussed, right? It needs the understandable format. So now how much time is required to convert your raw code into the understandable format? If the code is very huge, it needs 10 minutes of time to convert it. If the code is very small, then it will take less than a minute. Now, based on your code, based on your application, now the time can be vary. If your application is huge, then it's taking 15 minutes of time to convert, then that's it. Again, not acceptable. So that's why, right, what we will do, we are going to store the artifacts, whatever, right, the changes we received, the changes artifacts, we are going to store it. Like login 1, then here login 1.var. Then the second changes, then login 2.var, like that. For every change, right, the artifact will be stored. So then when something wrong, right, then immediately what I can do, I can deploy the login 1.var. That's it. You don't need to go and run the process again. That's the right. Artifact storing is going to play a very, very important role for us. When you want to recover the changes, you are not going to take the code. Simply you are going to take the previous version of the artifact, then deploy it. Hardly take less than a minute seconds. Take the copy and place it. That's it. Right. So now this process, right? This process will be called as a continuous integration process, CI. When the changes are done by the team, right, they will push the code to the version control tool. From that, your integration tool, right, will be having a job for every change, and the job will be triggered. A job is nothing but set of tasks. Those tasks are going to execute one by one. If any issues, it will fail and it will send a communication, or else it will go the next step task, then it will complete it. Nothing but storing the artifacts. Now this process, right, we are going to call it as a continuous integration process, right? So now we are going to automate this process. We are not, no one is going to do it manually by using, right, these tool stack, whatever the tools we discussed here. By using this tool stack, we are going to automate this process so that no manual intervention is required at any stage. Automatically every stage is going to complete it by its own. If something wrong, it will fail. Otherwise, it is going to complete by its own. Nothing but your process, right? So now, what is the tool stack that we use here? The continuous integration tool stack, right? Version control tool like Git, then Jenkins, then Maven, then Sonar, then Nexus. This is the tool stack, right? We are going to use it for the CI. Now the CD process, right? Continuous deployment process. The CD. A deployment into where? Deployment into the environments, like we discussed, right? One of the role, managing the environments, right? So now continuous deployment into the environments, into the servers. Like here, the first environment will be my development environment. That's like we discussed, right? We are going to have the bunch of servers, like a group of servers here. So now what we need to do, right? I want to deploy my artifact into the servers. So like we discussed, right? So before you go and run your application on the machines, we need to make sure the prerequisites, the setup, like whatever is required for the application to run, or these guys are installed or not. If not, right, your code is not going to work. Right. So this is the code developed with the Java 11, but on the servers we have the Java 8. Right. Upgrade to 11. Otherwise, this code is not going to work. Right. So now how we are going to set up the prerequisites on the environments. Right. Manually, it will take the time, and also maintenance will be very complex. One server, two servers is enough. Very right. It's easy for us. We can do it, but when you're dealing with hundreds of servers, it's a complex thing for us. We cannot do it manually, right? So there we have a tools called, right, we have a tools called configuration management tools are came in the picture, like Ansible, Chef, Puppet, right? So now by using these tools, right, we are going to manage the servers in the environments, like configuration management, like installations, config changes, version upgrades, whatever is required to run the application. Right. So now these two guys are lose market. Right? They are gone out of the market. Somewhere the chap is using Puppet is out of completely market. Right. So now the Ansible is the one who is leading the market. Right. So now by using this config management tool, right, we are going to make sure the prerequisites are taken care before the application is going to deploy in the servers. Right. So now who is responsible? It is our responsibility. DevOps folks are responsibility. We are going to write the Ansible automations. Right. So then once you have the code ready, then by using those automations, we are going to deploy the code into the servers. So right. So now here there are two things. One is taking care of the config changes, like the prerequisites. And the second one is deployment. Like here, your artifacts deployment. So now config changes, nothing but the setup, and the second one is the deployment. Now two things should be taken care. Earlier, right, the team used to write the scripts, the shell scripts are all the things to make sure these things. But at the shell, the problem is that when you have the huge servers, it will go and run one by one. Take the server one, deploy it, take the server two, deploy it. Like here, is taking a lot of time. So now these guys will deploy or will make sure everything in parallel. So 100 missions or 1000 missions or one mission, it can be in the same time. Parallel is going to take care, not by sequential, saving a lot of time for us. And also writing the code is very easy when compared with my shells or the bash. writing the code in the right in Ansible or Chef or Puppet is very easy, and also managing also easy. Maintenance, right? Writing a code can be done anyone, right? I can write the code if I have the good experience. I can write the code in 10 lines, right? If I'm not going to have that much of experience, now I might take few more lines, like 20 lines of code. But end goal is right. We are going to reach the target. It can be 10 lines of code, 20 lines of code, or 100 lines of code. But maintenance, right? If someone is going to maintain a code, now you have the 100 lines of code, that is a problem. Understanding each and every line and right try to fix those things means is a help for them. That's what the hurdle for us, maintaining of the code. Now here once these tools came to the market, right, they will have standard structure, so that right you have to follow those structures so that anyone can maintain the code easily. Anyway, we'll see it. Right. So now with this configuration management tools, right, we are going to make sure infrastructure is properly ready and it has right deployed into the servers. So then the dev team, like we discussed, right, the dev team is going to validate the code, and once the code is right validated properly and we have the proper outcome is there, then the code will be deployed right into the QA environment. Right. Again, right? Again, with the same tool, we are going to manage the servers and we are going to deploy the code from the dev to QA. Right. So likewise from the QA to UAT, then UAT to production. Right. So the respective teams validate the code, like we discussed, right? Dev team, testing team, client side team, then finally production. Once the team validates the code and it got the approval, right, it will go one by one, then finally it will reach the live. Right. So this process, right, we are going to call it a continuous deployment process, CI and CD. Right. So now, right, for the CD, right, what is the tools we are going to use here? Right here, I'm using the Ansible to manage the server and as well as to deploy the code. Right. So this is for monolithic applications. This is for right monolithic applications. So monolithic means that you have the application and the entire application is bundled. Like here, my login and debit card, credit card, online banking, like that. Your application is entirely right bundled into one single file, like your zip file. Now, what are the challenges we are facing with this monolithic, right? So, if something wrong with the online banking, your entire application goes down because they're bundled, they're packed, right? If something wrong with the right with one service, it's going to impact the entire application. That is the challenge, right? We used to face with the monolithic. So right, so now to overcome these challenges, right, microservices came into the picture. From the mono, microservices are came into the picture. So that right, you don't require to run the entire application is a single bundle, split them into pieces. So now here, run them individually. Like here, I'm going to run the credit card individual, debit card individual, my login individual, like that. My online banking individual. So now, right, previous right, they are bundled as a single pack, and it is going to run on a servers. Right. So now they have divided into pieces. Then these pieces are going to run individually, so that if something wrong with one of the like online banking, no issues. The particular server or the service will be fair. The rest will be active. Right. So that right. So customers are not going to face the application downtime issue. Only the particular service will not be available. At some point of time you might observe this thing, right? You when you're trying to browse, right, go to the application services, right, some point of time the service may not be responded, like our Paytm services or e-commerce services, like particular so particular time like 5 seconds, 10 seconds, or 1 minute to 5 minutes, like that. But the rest of the services will be available. So how they are available? Because of this microservices nature. The architecture is in the backend, right? They are running on a separate servers. This model is called as a microservice model, right? So earlier monolithic, and now, right now, right, we are using the microservices model to run the applications. Now, whatever, right, the process we discussed here, right, so that is for the monolithic application, because, right, we don't know, right, what type of application we are going to work. It can be mono or microservices. The legacy ones, right, still the monolithic. The latest ones, right, are the convertible, right, so the applications can be converted, they are converted to microservices, right? So now these microservices, how we are going to manage it? How these microservices are going to manage it? Means on the environments, how we are going to run them. So right, so right earlier, right, so here is a single bundle. So what I will do, simply on the servers, I'm going to deploy the bundle like this, the entire bundle to the application bundle. But here they are going to run on a different servers, individual pieces. Like, so now how we are going to manage them? So for that, right, Docker and Kubernetes came into picture. Docker and Kubernetes. So now what we will do, right? So now here in our process, so once the code got ready, your Jenkins job is going to trigger the same thing. Pull the latest code, run the test cases, code quality is going to check. Here the artifacts are there, right? So here we are not going to create the war files or jar files, the artifacts. Here, right, we are going to create the Docker images. The task will be, right, create the Docker images. What is the Docker image here? Right, so like we discussed it, right, so here the debit card is going to run on a separate server, right? Now on the separate server the debit card is going to run. Now what is the OS you are going to use? Right, now things are taken care, right? OS, which OS you are going to use? Suppose Ubuntu, right? So now this code is developed in Java version. Which Java version you need? Like Java 11, like web server, right? Whatever web server you want to do, like Tomcat I need. Who is the user is going to manage the application? Like here Tomcat or suppose Shankar is the user you want to manage. Right. So now here to run this debit card, right now these are the prerequisites. Like you need a OS server, and OS server means Ubuntu server with the Java 11 and the Tomcat is required, and the user called Shankar is needed here. Now, right, how we are going to set up these things? Now this is only for the debit card. Likewise, right, I have the credit card. Again for the credit card, different setup. For the online banking, different setup. Likewise, right, each service has their own setup. Right. So how we are going to take it? That's where, right, Docker is came into the picture. Right? Because this Java 11 is required will not be known by the DevOps engineer. It is the developer responsibility, right? So they know which version of the Java is required, which dependency is required for the dependency, which version is required, right? What kind of, right, setup is required for the configuration side, like everything they know. Because they are the owners, they developer the code. Right. So right, so for that, right, now the Docker, what the Docker has done here, it is simplified the things. Right. So now here they don't require to come to us and tell us like, hey, these are things need to be taken care. Now simply, right, they can create a Docker file. They can create a Docker file. So with all the things like with the OS, Ubuntu, like in the Docker file, they will mention what type of OS required, then, right, what the Java was required, then what the web service setup is required, like that. They will mention everything in the Docker file. Right. So now what you will do in the process, right, we'll take this Docker file as input and we'll create the Docker images. In our job, we are going to take the Docker file as input. The Docker file is nothing but the setup to run the application. Whatever the setup is required, they are going to write it in the Docker file. Then we'll take the Docker file, we'll create the Docker image. And these Docker images are going to store again for the revert purpose. Store the images. Like here again, we are going to use the hubs, Docker Hub or ECRs or ACRs like that. Right. So then once the images are added, earlier, right, we have the WAR files or jar files, now the Docker images. Now once the images are added, then what next? Deployment, testing. We have to test the code. Where we are going to test the code, right? Again, on the environments like dev, QA, staging and everything. But earlier, right, we have the monolithic servers and the server setup and then straightforward take the bundle and deploy it. Now here, it is not a single piece. Here, right, we are going to deploy into multiple pieces into multiple servers. Like here, my debit card has a separate server, my credit card has a separate server, my online bank has a separate server, my mutual funds is a separate server. Now, right, running on different servers, my one piece of application, one copy. When I want to maintain the high availability, again I need 4 more servers, like 4 plus, right? Because 4 servers are one set for my application. Again, I need 4 more servers to run the copy, like 8 servers. Now see, cost is increasing here. Earlier, right? So entire application is a one package, one bundle. Hardly 2 servers are enough to maintain the high availability. Now, my application has 4 modules like debit card, credit card, online bank, and mutual funds. For each service is going to run on a separate server. So now to run my entire application, I require 4 servers. To maintain the high availability, right? Again, 4 more servers, 8 servers, 2 servers to 8 servers. See here, the cost will be very huge there, right? And also, right, this has to communicate one each other because they're all one application. They have to communicate one each other. Now who will take care of this? That's where, right, Kubernetes came into the picture. Right. So Kubernetes is an orchestration tool, right? It is going to have a group of servers, like 2 missions or 3 missions based on your project. Now, whatever, right, you want to run your application, whatever you want to run, those application will be deployed as a Docker containers in the cluster, in the Kubernetes cluster, like this. 4 copies will be run on the cluster. Now this Kubernetes will taken care of, right? High availability, scalability, everything. You don't require to set up anything extra. You have to pass a proper instruction to the Kubernetes cluster. Make sure, right, high availability is maintained. It will take care. High scalability is maintained. Take care. Security is required. Take care. You have to pass proper instruction to the cluster. That guy will take care. So now Kubernetes, right, again solved so many issues and simplified so many hurdles, so many complex things got simplified in the Kubernetes. That's why, right, Kubernetes is one of the hottest tool in the market to manage the microservices. Right, these are all the painful things in the past for the admins or ops engineers to make sure they all these things. Now here it's become very simple. Anyone can manage it if they have good understanding, they have knowledge on the tools, they can manage it. Like how these tools are built. Right. So now in our microservices, right? So now here the CA part will be, right, similar for the microservices. Like we'll be having the Git, Jenkins, Maven, Sona. Then here Docker will come here. And for the CD, right, for the deployment, you will have the Kubernetes. Now see different tools, right? Different tools and different tool stack for the CI/CD for the monolithic or microservice applications. Right. So right now as a DevOps engineer, right, we are going to use these tools and we are going to create the automations for the CI/CD setups for the applications. It's a mono or it's a micro, whatever it is. Right. So now we are going to, as part of our course, right, we are going to discuss all these tools and we are going to see the entire flow. Whatever the automations we discussed, right, the entire flow we are going to see with the practical. We will take, right, total 3 projects, one for monolithic application setup, and the second one is the microservice application setup, and the third one is infrastructure automation. Right. So where I'm going to cover, right? So your high availability, scalability, security, all the things, infrastructure. With the practical, right, we are going to see all the things. Right. So I hope we are clear until this point.
So
On the
I do have
CIC,
a couple of questions
yes,
here. So
yeah,
you
yeah.
said the Docker images, right? Simply
Yes,
because when we have multiple, I mean, microservice architecture, you're saying that. So can't we have that one with the regular artifacts? What we do in general for the monolithic?
yes.
Can't we
So
have
in the
multiple
multi,
artifacts and yeah, and can
yes,
achieve the
yes,
same thing what we are doing with Docker?
yes, exactly. So here the, so yeah, let me clarify that doubt. We can have a separate war file like debit card war, credit card war, right? Online bank war like that, right? So, but when you are deploying them on an individual servers, right? So, suppose here on this server, I'm going to deploy the debit card war, and on the other server, I'm going to deploy the credit card war like that, right? So, this is can be done, but the problem is, right? So how they are going to communicate, right? Because at the end the user is not going to bother about you are running in a one server or multiple servers. I want to access the debit card, right? Simply I will go and click on the debit card so that I can access the debit card things. When I want to switch to the credit card, then simply I will click on the credit card. In the back end, these guys has to be communicate one each other. This configuration, right, you have to be taken care. And also the setup, right, like we discussed. So for the debit card, we require the Java 11 as an example. Java with 11 is required. Right? So here Java is 8 is required, like different versions. Right. So now again, right, you see here. So now you can set up the things, but here the complexity is increasing, right? In the back end, you have to take care of a lot of things. It's not like simply running the code. That's what that Docker file is mentioned here. It is not like simply running your code. It is going to take care of a lot of things. Which OS is required? Right here, you need Ubuntu. Suppose for this, I need Red Hat. As an example, I'm telling you like the complex things. You have to take care of these things because the war file is not going to have the OS. The war file is not going to have the linking. The war file is not going to have the Java version 11 or something. Right? Simply code. It's a code, the canonical code. But here, you need to take apart from the code a lot of things. So that's where the Docker is going to take care. You don't need to do all of it. Simply you can mention the Docker file. It will spin up everything for you within seconds.
Oh,
Within
great.
seconds.
So it simplifies the
Yeah.
configuration part, you're saying. Okay, okay,
Yes,
got
yes.
it.
So it is going to take, you're going to take care of other part also. So that because right, the time is the factor here, right? So you have to achieve the your targets in on time. Anyway, right, when you go to the Kubernetes, there you'll see the advantage with this Docker and the containers, right? So you will see like the future, then you'll realize oh, this is the great thing we are going to achieve with these tools. Yeah. Any other questions? Okay, fine then. So I hope right we are good here until this mono application setup and microservice application setup. So there are right few more tools are there to discuss for us. Uh, like one is the cloud, and the second one right is this is our cloud, right? AWS services we are going to discuss about, and we are going to cover in a project like there are services to manage our application, and right. So then we have one more piece is there like the tool things, Terraform. Right. So in our next class, right, we'll discuss about the monitoring part. We have the three pieces actually: CA, continuous integration; CD, continuous deployment; and the third one, right, continuous monitoring, CM. Right. So we'll discuss about the CM part, and also we have one more piece is there like log streaming, how we are going to manage like the ELK thing, Then right, we'll discuss about the cloud. With the cloud, right, what we are going to achieve with the cloud, and right, what are services we are going to use. Then right, we'll discuss about the Terraform. What exactly the Terraform is going to do. Right now is that Terraform is one of the hottest tool in the market, right, to manage the infrastructure, right? How the Terraform is going to use. Right? These things right will cover in our next class. Right. So now when it comes to the course, right? So these are the tools you can observe here, right? So these are the tools we are going to cover in our DevOps area. DevOps tools, and these are the AWS services we are going to cover. So from the scratch, right? So every tool will be covered from the point zero. So we'll see the setup, installations, configuration. Then we'll go and work with the tools. Every tool will be covered with the basics, and we'll go to the deeper level, right? So then, like I mentioned, right, we are going to cover a total 3 projects to understand the microservices setup, mono setup, and this AWS services setup, like infrastructure setup. So that right, we'll be having a good understanding on these tools, on these services. So material, right? I'm going to provide the material to you, right? For every tool, a separate PPT, right? I'm going to share it to you so that, right? So that PPT is going to have everything. So with the explanation, as an example, right? If I go and take this Maven guy, open it. Okay, let me open it. Okay, that's one thing. Here I don't have this PPT thing. That's where the problem is. Right. Suppose if I take this Jenkins, right? So right, the PPT is going to have the right everything, the material installation to write. So with the screenshots, every tool will be covered in the same fashion. Right, once you install it, what the output you are going to see, everything is explained with the screenshots. So this is the material that I'm going to provide for every tool. So whatever you're going to cover in our DevOps area. And also, right, so we'll go and see with the interview questions, right? So, right, so whatever the topics we are going to cover, right, we are going to focus on the interview questions also. Like this is the area, right, where the interview questions might come, like that, right? We'll cover the interview questions also along with the topics, so that right we can have some focus on those areas, right? So then for the practical, right, so you don't require to have any kind of separate configurations or right for your laptop or desktop. So since we are going to use the cloud here for the practice, because one single machine is not sufficient for the DevOps practice, we require 3 to 4 servers, because right, as we discussed the flow, as per the flow, right, we required this tool setup. For this we require right 3 to 4 servers. So that's why right, we'll go with the cloud and we'll utilize the cloud services, then right, and we'll practice our DevOps. So that right, you guys don't require any configuration of your laptop or desktop to practice. So everything we are going to take in from the cloud. And, I will show you right how to use them and everything. Right. So that is from the configuration side of your missions. And right. So yeah. So these are the things. If any questions, anything, right, do let me know, guys. So
Sure, and also you have to explain the live scenarios like demo project
yes,
like
yes,
that's
yes,
all.
yes, yes. Yeah. So
Mhm.
we are going to focus completely with the live only. So here we are. So this course content is something like you can straightforward completed with 3 to 5 years real time DevOps engineers. Like we will go and see every scenario, right?
Okay.
So whatever I work and whatever the scenarios we face and everything we are going to discuss along with the course content. So that right,
Mhm.
straightforward you can go and compete with them like that.
Yeah,
No
what
worries
will be
about
the
it.
real scenarios means like
Yeah.
you can face the live scenarios in your project, so you can
Yes.
explain
Yes. Yes.
those things. It will help more, I think.
Yeah. That is going to cover. Yeah. No issue.
Yeah. And also, what is the timings daily that one?
The timings actual, right? So right now we are in discussing, like we are planning for morning 6:15 to 7:30 like that. Good.
6:15 to 7:30.
Yeah, 7:30.
Okay, okay.
So
It means
whether
8:30, I think.
That's it, sir.
Right. Will the our
Thanks.
admin team will contact with you guys so they will see the feasibility time, like measure the students that feasibility time. Then right we'll plan for right now the timings you are for planning for like morning timings like 6:15 to 7:30 like that.
So I'm not getting. Say again.
Sorry.
Can you say again, sir? I'm not getting.
Yeah. So what I'm saying here, right? So right now, right, we are planning for morning timings of India, 6:15 to 7:30.
Mm-hmm.
So right, anyway, our admin team, right, will contact with you guys and right, see the feasibility time for you guys, and will right, maybe if anything is required, we can work on that part. Okay.
Yeah. Okay. Sure.
Because
Thank you.
right, 7:30, I have a separate batch running. That's why right, 7:30 time I'm not able to take it. But anyway, like we'll see that part, the timing part.
Yeah. Sure. Sure. Yeah. Our hours in night time, so that's why I'm asking.
Yeah. Okay.
Yeah.
Yeah. Yeah. Anyway, we can see, we can discuss about that.
Yeah. Sure.
Yeah. Any questions on the technical side, like the fees and everything, right? The timings and fee, right? Our admin team will take care of that. So just we can check with them. So technical, right? From the DevOps side, the tools, whatever we discuss, right? Any questions or anything, right? Do let me know, guys. So that right, I will happy to clarify your doubts. Anyway, we have one more session is there. There also I'm going to cover the cloud part and as well as right the other tools, whatever is left. So I'm going to cover those also. Then we start to our actual classes.
Sure. Sure.
So yeah. So again, right? So
Opportunities.
yeah. So again, right? One more point I want to discuss here. So to learn this job, right, you don't require any prerequisites. So like I need to have some kind of experience on this, or I need to have some kind of knowledge on that, like that. We don't require anything. But one is right, if you have the knowledge on areas like because you are going to touch the admin part, like OS, service management, like that. We are going to touch right build and release part. We are going to touch right ops part, like automations, like installations and all the thing. If you work on those areas, that is going to helpful for you. If you are not working on that area also, not a problem because we are going to cover everything from the scratch, from the basics. So like we are going to learn right from the point zero to right point 100, like that. So every tool will be covered in the same fashion, right? One of the things
Yeah,
is right
sir.
from your end. Yeah.
You can explain the Linux also, sir.
Yes, yes. So I'm going to cover the Linux part also. Yeah. If you guys observe here, right? So let me, yeah. So here, Linux with the, again, don't think like I'm going to cover the complete administration part of Linux because it is a ocean, right? You guys know. So learning that OS part is like will take a lot of time. But anyway, so we don't record all those areas. So whatever the important commands are there for our day-to-day work, so those commands are going to cover here. Like almost 50 commands I'm going to cover. So which we are going to use in our day-to-day life, right? So later on, whatever the concepts are required, you can learn yourself. Right, because our area is continuous learning area. Like it's not like one time you learn it and leave it. Right, right. Daily new tools are right, new areas we are going to touch. We are going to understand them and we are going to use them. But anyway, majority of the area I'm going to cover here, like 80 to 95%.
Mm-hmm.
So like hardly 5 to 10%. You need to focus on the other areas. So like here, I'm going to start with the Linux. So we'll go and see some important commands, some important areas. Then we'll go for our DevOps areas. Then right, we are going to see the scriptings also, like here shell and as well as Python scripting also I'm going to cover. So that right, automations with the scriptings. So because right, again, it's a project nature. Like sometimes that the client don't want to spend much right amounts on the tools. They want to have the available tools like free tools, and they want to have the automation. Then we'll go and use the scriptings, right? So because if I want to go and use the Kubernetes or some other tool, that we have to pay something there. They don't want to go with them. Then again, we'll go for the automations with the scriptings. So that's why right we are going to cover the scriptings also now with the shell and Python. So likewise.
Okay. Yeah.
Right, so that's the right. So here everything will be covered from the scratch, from the basics. So if you have some knowledge on the area, that is helpful for you. Otherwise, not to worry, everything will be covered here. So just your job is to practice, practice, practice. Lot of practice is required, right?
Yeah.
So because right, so yeah, if I start learning the Java, right, I will start the learning of variables, conditions, loops, classes. right? Core Java, advanced Java, like that, a flow will be there. But here, Git is a separate tool. Jenkins is a separate tool. There is no link there. We are going to make the link. Like Docker is a separate thing. Kubernetes is a separate thing. Terraform is a separate thing for us. So, right, we are going to establish the linking, but there is no flow with the tools. Like here, if you learn the Git, Terraform is same. Like I can go with the Git to Terraform. It's not like our core Java to advanced Java. So here, separate tools, separate areas, separate automations, separate concepts for every tool. So that's why, right? If you start practicing a lot, right, you will understand everything. So my job, I am going to give everything for you, like for the course, the understanding, the architecture, the concepts and everything. But if you are not practiced, right, you will understand things, but you are going to lose it in the next 5 to 10 days if you are not practiced. That's what from your side, what you guys need to do, practice, practice, practice. That's it. Rest of the things I will take care from the technical point of view. And the job market, right? So right, not only right now, right, DevOps is having very huge demand in the market, very very huge demand, right?
Yeah.
And also they're offering, right, the packages. If you have the good skills, they are not going to focus on the package also, right? So whatever you are asking, right, we are expecting they are going to give more than that, right?
Sure.
So a simple example, right? So here I am having 11 years of experience, right now my package is 60 lakhs plus in India, not in other countries, in India itself only. Okay, you can assume that. Okay, so that kind of demand is not 60, 60 plus. I don't want to give the exact figure. It is more than that. Okay,
Yeah.
so that's why the DevOps is here, the demand of the DevOps. So right, so in my right again, so for the practice time, I'm going to create the groups also, like here. So one major thing is, right, so the practice should not be stopped at any area. So here I have the different batches running. So my students who are practicing continuous, like the everyday topic they are covering, so they are getting the jobs in the course itself. Like the course is still is going on. They are placed actually. So
Mhm.
yeah, like that. So I want to give some examples here. Okay, let me search it. Like here, right, we are going to create the batches, groups, WhatsApp groups will there. Here you can practice it. With the search. Here, right? So here, someone is already got the place, then someone is responding here. I also got on upfront TS with the 23 lakh package,
Mhm.
but I'm not joining because he is having, right, multiple opportunities. He's not able to go, like, so this is like June month only. My previous batch actually, like they are in the course is still going on. They already placed it, right? So likewise, my courses, particularly my courses, likewise I designed it. Okay, so your job is to practice, 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 practice. That's it, right?
Yeah.
You don't require to go for it. Like you don't need to depend on someone is going to offer you something. Just practice it and prepare the resume properly. I'm going to provide you, right, the how to prepare the resume and everything. Prepare the resume and place in the market. That's it. You yourself, you can crack the interviews and you can take the things also.
Okay.
Yeah. So that is
Yeah.
one thing that I want to tell you guys.
Thank you.
Yeah. Yeah. Any other thing? Right, and also, right, so my course duration will be, right, a minimum 2.5 months. So like I'm not going to go and cover basic concepts. We are not going to see the definition and everything, right? We'll go with the right concepts in depth, right, practically. So minimum, right, it will take at least, right, 70 days easily, right? If I take 1.15 to 1.30, like 1.5 hour per day, if I go and take 1 hour, right, it will go for 3 months. So that's why, right, so I'm planning for to take 1.5 hour like that, so that, right, we can target at least for 2 to 2.5 months like that. So every tool will be covered in a depth fashion, right? So this is the course, like you can take it at 2.5 months is our course duration actually. Okay, maybe if you go beyond also, based on our uh, the speed of the course, the pace of the course.
Okay.
Yeah. So I hope we are good. If no questions, right? Can we right? Let's wind up for today and write our admin.
Sir, sharing the videos also.
Yes, yes. Videos also, right? The recordings also will be provided. Yeah.
Can you share today's recording, huh?
Yes, yes, yes. That recording will be shared to you guys, to your maybe team will take your emails, right? How they are going to convey, like share the recordings. But yes, the record is going to share to you guys. Our team will be reach out to you. Yeah.
Mhm. Thank you.
Right. So fine then. Let's meet on our next session. Right. Our team will reach out to you and let you know, guys. When will be the next session? Most probably tomorrow or not. Right. They will let you know. So then we'll cover the rest part of the session. Then we'll go for the actual thing. Okay. So have a nice day. Thank you. If no questions, right? Let's find up for today. Bye.